The legs of a right triangle are A and B. Find the distance from the vertex of the right angle to the nearest point of the inscribed circle. The legs of a right triangle are A and B. So we have a right angle triangle in which we have one side is of measurement A, another side is of measure B. Find the distance from the vertex of the right angle to the nearest point of the inscribed circle. So a circle is inscribed inside the right angle triangle. We have to find out the distance from C to the nearest point of the inscribed circle. So to understand this problem, what we will do, we'll join O to C first. From C, we have to find out a point nearest point of the inscribed circle. That means from C, we have to find out a point on the circle which is nearest. When you observe, you can clearly see what are our candidates. We have one point here where it is meeting, another point is here, and all these points which are available. Out of them, the nearest point will be this point, which is C. Let us say that point is D. Now CD is what we need to find out. So let's write down. We need to find out CD, but that is equals to OC minus OD. Let the radius of this particular circle be R, in radius equals to R. Then what we have now is OC minus R. But what is OC? Let us understand what is OC. For that, what we will do, we'll drop perpendiculars to the point of contact. Now you can see that we have a square here. Why we have a square? Because we know these two lengths are equal and these are equal to R, and we have all angles 90 degrees with two adjacent sides equal length. That means it is a square. So square means we have all the sides are equal. So we have R here, we have R here. Now what will be OC? OC will be equals to square root of, let us say this is D and this is E. Then we have OC equals to OD square plus CD square, which is equals to R square plus R square under root, that is equals to root 2R. So CD is equal to OC minus OD, that is equals to root 2R minus OD is equals to R. So we have root 2 minus 1 into R. So the nearest point is at a distance of root 2 minus 1. Nearest point is at a distance of root 2 minus 1 into R. But radius is not given to us, only given to us are A and B. So R should be written in the form of A and B. So let us see how to find out R in terms of A and B. So for that, what we will do, we'll go back to our right triangle, and we know that CD equals to R, then AD equals to B minus R. We know length of tangents drawn from an external point to a circle are equal. So if AD equals to B minus R, then we can say that AH is also equals to B minus R. Similarly, CE equals to R, CE equals to R, then what will be BE? BE will be A minus R. If BE equals to A minus R, then BH is also equals to A minus R. So let's go ahead and write down steps for this, whatever we have discussed just now. So we have length of tangents drawn from an external point to a circle are equal. So we have AD equals to AH, BE equals to BH, also CD equals to CE. So let's write down that we have CD equals to CE, AD equals to AH, and BE equals to BH. We know that CD equals to CE equals to R, as ODCE is A square. So then we can write down AD equals to A minus AD equals to B minus R, and BE equals to A minus R. That means AH is equals to BH is equals to AD is equals to AH. So AH is equals to B minus R, and BH is equals to A minus R. That means AB is equal to A minus R plus B minus R, that is A plus B minus 2R. But what is AB? AB is hypotenuse of this right angle triangle. So we can write down square root of A square plus B square equals to A plus B minus 2R. R equals to A plus B minus square root of A square plus B square divided by 2. Now let's go back to what we got our distance CD. We got CD equals to root 2 minus 1 multiply with R, which is nothing but equals to root 2 minus 1 divided by 2 into A plus B minus square root of A square plus B square. If we know that AB equals to small c, if you take, then you can write that in radius is equals to A plus B minus c divided by 2. That is the formula which we can use if we know that C is the hypotenuse of the right triangle and AB are sides, then R equals to A plus B minus C by 2. Now in this problem we have to find out from the vertex of right angle the distance from the vertex of the right angle to the nearest point of the inscribed circle, that is CD. CD is OC minus OD. OC is root 2R because it's a diagonal of the square, and OD is R. So CD is root 2 minus 1 into R. Root 2 minus 1 into R. R is A plus B minus C by 2. But C is equals to square root of A square plus B square by Pythagoras theorem. So CD is equals to root 2 minus 1 divided by 2 into A plus B minus square root of A square plus B square.